Welcome to the discussions of the past year questions. This video, we shall take a look at the mechanics. February-March 2024, paper 42. Let's take a look at the first question. We have a diagram over here. The displacement of a particle at time t second after leaving a fixed point O is s meter. So this is the s meter, this is the t second. Okay. The diagram shows a displacement time graph which models the motions of the particle. The graph consists of 4 straight line segments. The particle travels 50 m in the first 10 seconds and travel at 2 meters per second for a period of 10 seconds. The particle then comes to rest for a period of 20 seconds before returning and return to its starting point when t equal to 60. Okay, so these are the descriptions. Then we want to find the velocity of the particle for the last 20 seconds for the motion. We want to find the velocity. So for the velocity, that means we need to find the gradient. And the gradient, we need to find this point. And this point, we know this point is a 60 and 0. We need to find this point as a 40 and we do not know the value here. So this value is connected to here. Okay, so I call this one the value D, representing the distance. So this D is the second stage. It takes 10 seconds. So at the second stage, you're actually traveling at 2 meters per second. Okay, so the value for D is actually on top of 50. From here, you travel with a speed of 2 meters per second for 10 seconds. Then you get this one as a 70. Then therefore, your velocity for the last stage over here, it will be the gradient. That means now the D has become 70. Just use the gradient formula. Okay, just take this 0 minus a 70 divided by the 60 minus a 40, and you get the answer as negative 7/2 meter per second. So this is the answer for the part A. Now we're moving on to the part B. Sketch a velocity time graph for the motions of the particle from t equal to 0 and t equal to 60. So over here, we just need to draw it with a proper scale. So my graph may not be accurate. So when you draw yourself, please use a ruler and a proper scale so that you can draw it correctly and properly. So I have 4 stages over here, 0 to 10, 10 to 20, 20 to 40, and 40 to 60. Okay, so we have 10 second, 20 second, 30 second, 40 second, 50 second, and 60 second. Okay, then we know that the V over here is actually representing the gradient. Okay, we need to find the gradient for this one, gradient for this one, gradient for this one. And just now we have found the gradient for the last part. The gradient for the last questions is, just now the gradient for the last part is negative 3.5 or negative 7/2. Okay, we make it become decimal, easier for us. So this one will be negative 3.5. So what you need to do now is to find the gradient for the first stage. That is a V1, V2, V3. This V3, the gradient over here, horizontal line, the gradient obviously is a 0. Okay, so we need to find these two only, V1 and V2. How do you find the V1? So to find the V1, just take these 2 points. Find the gradient. Okay, so to save time, I just write everything over here. So the V1 is a 50 divided 10 is a 5. Then the V2 is a 70 minus a 50 divided by 10. And you get this one as the 2 meters per second. The V3 just now I mentioned is a 0, and the V4 actually is a negative 3.5 meter per second. Okay, so we need to draw this one 1, 2, 3, 4, 5. Okay, so at first it's 5. Okay, the line over here, this is 5. Then after that, this is a 2. And after that is a 0, is over here. Then after that is negative 1, negative 2, negative 3, negative 4. Negative 3.5 is here. So this one will for 20 seconds. Okay. And this one will be from here to here. Oops. Erase this. Okay. So this is the graph. So the graph should be like this, and this only. Okay. So this will be the graph for the VD graph for the motion that described in the questions. Okay, just like that. That is the answer for the number 1B. Moving on, we have question number 2. Okay, now we take a look at question number 2. A particle is projected vertically upward from a horizontal ground. The speed of the particle is 2 seconds. After its projection is 5 meter per second and is traveling downward. Okay, so after 2 seconds it's going downward, but with the speed of 5 meter per second. So we want to find the speed of the projections of the particle. So we will be using this formula. Okay, so the V will be a negative 5 because they mentioned 5 meter per second downward. The U is the value that you need to find. The A is negative 10 because you are going upward and you are against the gravitational force, and the time is 2 seconds. So therefore you get the U as a 15 meter per second. Done. Just like that for the part A. Then B, find the distance traveled by the particle between the two times which the speed is 10 meter per second. So the situation is like this. You are having a ground floor over here and you projected with a speed of 15 meter per second. So up to a certain stage, up to a certain level, your speed over here and the speed over here, they are both equal to the 10 meter per second. Okay, so we want to find that time is the T1. This time is a T2. We want to find the distance. We want to find the distance of here, that travel. So what you need to do is that we need to understand that let me erase this. No need to make it so messy. So we want to find the total distance. So you need to understand that this is the height and this is also the height, and understand that h1 is equal to h2. Okay, this is something you need to know. So the distance actually is 2 times of the h1. Okay, so we just consider h1, then just multiply by 2. Then we can find the total distance traveled between these two periods. Okay, so what you can see is that we have found that this is a 10. We has been informed that this is a 10 meter per second. When you reach to the top, your V is a 0 because at the maximum height, then is a 0. So what we need to do, just use this formula. Okay, so we have a 0 square is equal to the 10 square plus the 2 of negative 10. This is a h1. So your h1, it will be 100 minus, divide 20. 100 divide 20 is a 5. So therefore, your distance is equal to the 2h1 is equal to the 10 meter. Just like that, done. That will be the answer for the question number 2B. Moving on, question number 3. Okay, now we take a look at question number 3. A crate of mass 600 kg is being pulled up a line of greater slope of a rough plane at a constant speed of 2 meters per second by a rope attached to a winch. The plane is inclined at an angle 30 degrees to the horizontal, and the rope parallel to the plane. The winch is working with a constant rate of 8,000 watts. Find the coefficient of friction between the crate and the plane. So we can have a diagram over here just to describe the situation. You have the winch over here pulling the particle up. This is the tension. This is the normal contact force. This is the weight, which is a 6,000 Newton. And this is the frictional force. So if you resolve the forces perpendicular to the plane, you have R, I forgot to write down this one, 30 degree. You have R is equal to the mg cos theta, that will be 600 times 10 cos 30 degree, that will be 3,000 sub 3. Then your FR is equal to the mu R. You do not know the mean, and you do not know the mu, so you just write 3,000 sub 3 mu. Okay, so that will be the frictional force. Then if you resolve the forces parallel to the inclined plane, you have the pulling force, or the T, minus the mg sine theta minus the frictional force is equals to ma. Okay, is equal to ma. But dimension is a constant speed. Okay, so it will be the T is equals to the mg sine theta plus fr because of our constant speed. Constant speed means your acceleration is a 0. Okay, so your m 600 g is 10 sine theta sine 30 degree. Your fr is a 3,000 3 mu. What about your tension? So over here you need to understand that they're giving you power. The formula for power is actually the tension multiplied by the speed. Okay, tension multiplied by the speed. So the tension is actually the P over V. P over V, yeah? Okay. Maybe we can just change this T become P over V over here, so that we can have this when the V is equal to 2. The question mentioned that the speed is 2 meters per second, right? So this one, the power is 8,000 watts over 2. So this is what we have. So from here, just use your calculator, then you get your mu. Just press everything using calculator. Okay. Okay, or maybe you can simplify first before we press everything using calculator. We have 3,000 3 mu is equal to the 4,000 minus the 3,000. So your mu is equals to the 1 over 3 sub 3. 1 over 3 sub 3, you can make it become sub 3 over 9, or you can make it become decimal of 0.192. That will be the answer for the question number 3. Done. Moving on. Question number 4. Okay, now we take a look at question number 4. 4 coplanar forces act at the point. The magnitudes of the forces are F Newton, 2F Newton, 3F Newton, and 30 Newton. The directions of the forces are shown in the diagram. Okay. Given that the forces are in equilibrium, find the value F and the value of theta. This one is very routine. We just need to resolve the forces vertically, and you have a 30 sine theta is equal to the F plus the 2F cos 45. So we can just factorize the F out. Then you get this one as an F, a 1 plus square root of 2. Okay, so this is the equation number 1. Now you resolve the forces horizontally. If you resolve the forces horizontally, then you will get this as the 3F plus the 2F sine 45 is equal to the 30 cos theta. So we can write this one as a 30 cos theta is equals to the F of 3 plus sec 2. That will be your second equation. Taking the first equations divided by the second equations, you will have tangent theta is equals to the 1 plus sec 2 divided by 3 plus sec 2. Okay. Pressing the calculator, you can get the answer for the theta is 28.7 degree. And from here, we just substitute into either equation 1 or equation 2. Then you can get this F is equals to the 30 sine 28.7 degree over the 1 plus 2. And you just press the calculator, your answer will be 5.96, correct to 3 significant figure. Done. That will be the answer for the question number 4. Okay, so now we're moving on. Question number 5. So now we move on to the question number 5. They give you a particle move in a straight line starting from a point O. The velocity v meter per second of a particle t second after leaving O is given as following here. You may assume that the velocity of the particle is positive for t less than half and 0 at t equal to half and negative for t greater than half. So the distance find the distance traveled between t equal to 0 and half. Okay, so the distance traveled between 0 and half, that means you just need to find the integrations from 0 to half. Okay, because they mentioned less than half is positive. That means it's above, the graph will be above the horizontal line, the horizontal axis. So just need to integrate the v, t cubed minus a 9 over t squared plus 1 dt. Okay, so integrate this, you get t power 4 over 4 minus the 3 over 2t cubed plus the t. Then you just need to substitute half and 0 inside. You get this one as a 1 over 64 minus the 3 over 16 plus the half minus the 0. Press the calculator, you get 21 over 64. I will just leave the answer as an exact value form like this will do. So this will be the answer for the part A. Now we're moving on to the part B. Find the equations. Find the positive, not the equation. Find the positive value of t, which the acceleration is 0. And hence, find the total distance traveled between the 0 to that instant. Okay, so to find the acceleration equal to 0, we need to find dv dt, because the dv dt is accelerations. So you differentiate the equation, it will be 3t squared minus the 9t equals plus 0. Okay, then you let your dv dt equal to 0. Then you get 3t t minus 3 equal to 0, t equal to 0, and t equal to 3. This case, you need to ignore it. Okay, so therefore the answer is 3 seconds. So in order to find the distance, total distance travel between 0 to that instant, okay, because they mentioned that the graph, from 0 to half, you are at positive, okay, you are at positive direction, something like this. When t equal to half is a 0, then after that is negative until 3. This graph is just an assumption only, okay? D equal to 3. So we need to find the area over here and then plus the area over here. We need to find the area separately. Okay, this one we already found in the part A. We know that this distance is 21 over 64. Now we need to find the second part over here, this area. So how are we going to find the area over here? We just need to write down the D is actually equal to 0 to half of the VDD plus the integrate. Okay, I think to save, I think I erase this to get more place over here. Okay, so over here, the V, this one I just write VDD. This one is minus, again, plus a modulus half until 3 of the VDD. Your V is a D cube minus the 9 over 2 D square plus 1 DD. Okay, modulus. So this already known from part A, we already know it's a 21 over 64. Then this one is modulus. We still put modulus. This one is a D power 4 over 4 minus the 3 over 2D cube plus D. And then we going to substitute 3. We're going to substitute half and 3 inside here. So over here, if you just substitute the value, then you will get this as the 81 over 4 minus the 81 over 2 plus 3 minus the 1 over 64 plus minus the 3 over 16 plus a half. So just total up everything, you will get the answer as 573 over 32 meter. So that will be the total distance traveled between t equal to 0 and the instant that the acceleration equal to 0. So this will be the answer for the question number 5. Moving on, we have question number 6. Take a look at question number 6. A car of mass 1,800 kg is towing a trailer of 300 kg up a straight road incline at an angle alpha to the horizontal, where the sine alpha is equal to 0.05. And the car trailer are connected by a tow bar, which is light and rigid and parallel to the road. There is a resistant force of 800 Newton acting on the car and a resistant force of the F Newton acting on the trailer. The driving force of the car's engine is 3000 Newton. Given that F is 100, find the accelerations of the car and the tension in the tow bar. So we can have a small diagram over here. It's going up the hill. This is the trailer. This is the car. Okay, so the car is moving up with the driving force of 3000 Newton. There's a resistant force over here, 800 Newton. There's a resistant force over here of 100 Newton because the F is 100. Okay, so these are the information given. The mass over here is 1,800 kg. The mass over here is 300 kg. Okay, so what you need to do over here, we have an angle alpha over here, where they give us that the sine alpha is a 0.05. So we can just compare, just focusing on either the car and the trailer separately. Okay, so we can consider car and the trailer separately. So at car, if you resolve the forces this way, you have the driving force minus the mg psi alpha minus the frictional force, okay, and then minus the trailer is minus the tension. Then you will get ma. So this is the car, and the car. Okay, so these are the information given. So what you can do now is your driving force is 3,000. Your M is 1,800. Your G is a 10. Your psi alpha is a 0.05. Minus the frictional force is 800. Minus the tension, which is you do not know, is equal to the 1,800 A. So if you simplify them, then you get this one as a 1,300 minus a T is equals to the 1,800 A. That will be my first equation. Now we consider the trailer. At the trailer, if you consider the forces going upward, you have the T minus the mg psi alpha minus the FR minus minus the 2 only. Okay, we only have 2, don't have other forces to minus anymore. Is equals to the MA. So this one is the trailer, and the trailer. So the tension you do not know. The mass of the trailer is 300 times 10 times 0.05 minus the frictional force of the trailer is 100 is equals to the 300A. So just by using calculator, you press everything, and if you simplify it, you get T minus 250 is equals to 300A. That will be your second equations. Take the first equation and the second equation, add together. You have this one as a 1050 equals to the 2100A. So from here, you can find your acceleration as half meter per second. Okay, your A, it will be a half meter per second. So now we move on. We need to find the T. To find the T, I just put into the second equation. The T is equal to the 300A plus the 250. Press a calculator, you get this one as a 400 Newton. Done. So this will be the answer for the question number 6A. Okay, now we move on. Question number 6B. It is given instead that the total work done against F is moving up a distance 500 meter up the road is 6,000 joule. Find the speed of the car. The speed of the car at start of the 50 meter is 20 meter per second. Use energy method to find the speed of the car at the end of the 50 meter. Okay, so over here they mentioned using energy. We need to consider energy. So the conservations of energy, we are having the work done by the car plus the kinetic energy at the very beginning is equals to the PE gain plus the work done by the resistance plus the kinetic energy for the final part. So these are the relationship that we can have. So work done by the engine of the car. The questions giving you that the engine of the car is 3,000, is a driving force of the engine multiplied by the distance travel plus the half mu square. This m is actually the mass of the car plus the mass of the trailer multiplied by the v square, u square. Is equals to the mc plus mt gh plus the work done by the resistance. So the work done by the resistance is actually the work done by the F by the trailer is 6,000 joule. So it's a 6,000 plus the work done by of the resistance of the car. The resistance of the car is resistance of the car 800 multiply 50. So it's 800 multiply 50. And then plus the KE final. The KE final will be the MC plus MT. it will be square. Okay. So now we just put in the things that we have. We have the driving force as 3,000. We have the distance is 50. We have the MC 1,800. MD is 300. The speed at the beginning is given in the question as 20 meter per second. N is equals to the 1,800 plus the 300. The G, the H over here, it will be 50 sine alpha, 50 sine alpha, plus the 6,000, plus the 4,000, and then plus the half of the 1,800 plus the 300 v square. So the sine alpha, we can actually straight away make the sine alpha become 0.05. Okay, yeah. So just press everything using the calculator. My left hand side, I get this one as a 5700 0. And my right hand side over here, I have a 52500 plus the 4600. Hundred. Yeah. Okay. Then this one, it will be 1050 v square. Okay. So this is what we have. This is what we have. Then, oh, I make a mistake. This one is not 4,000. This one, if you press a calculator, this one is actually 40,000. 40,000. So this one's supposed to be 46,000. Supposed to be 46,000. Press the calculator wrongly. Okay. So now just simplify everything, solve it. You get the v square. We straight away write the v. The v, square root it. Then you get this answer will be at 21.2 meter per second. That will be the answer for the question number 6B. Done. Okay, so now moving on, we have the question number 7. Look at question number 7. The diagram shows two particles P and Q which lies on a line of greatest slope of a plane ABC. Particles P and Q are each of the mass mkg. The plane is inclined at an angle theta to the horizontal where the sine theta is equal to the 0.6. The length of AB is 0.75 meter and the length of BC is 3.25 meter. The sections AB of the plane is smooth. So this one is smooth. And the sections BC is rough. The coefficient of friction between the plane particles and the section BC is 0.25. The particle P is released from A and rests. At the same instant, particle Q is released at rest from rest at B. Verify that the particle P reaches B 0.5 seconds after it released with the speed 3 meter per second. Okay, so over here, we just need to consider at B. So 3 seconds, B reaches B. So that means the whole plane over here is smooth. We know the distance is already known as a 0.75. So we just use a formula. Because it's smooth, so we just use U equal to the V equal to the U plus AT, where the A is a G sine theta. So it will be U plus G sine theta. So the U is a 0, the G is a 10, the sine theta is a 0.6, the time is 3 seconds. The time is 0.5 seconds. Press the calculator, you get the answer as 3. Okay, verify. So this is how you get the answer for the part A. Now moving on, we go for the part B. Find the time that it takes from the instant that the two particles are released until they collide. Okay, so until they collide, now we will, over here, to make it easy for us, we will start to calculate the time when P reaches the B. B reaches here, then the Q move a little bit of distance already. Okay, so now we consider the because it has a friction, we need to consider the normal contact force first because we want to find the frictional force. So this is the normal contact force. This is the normal contact force. Okay, this is the mg. This is the mg. They mentioned that both of the particle, the mass is m. Okay, so at Q, we can have a small diagram over here. RQ, mg. This is the theta. This is the frictional force. Okay, so sine theta is equal to 0.6. 0.6 is 3/5. We can actually draw a right angle triangle. 3 here, 5 here, that means this one is a 4. So from here, if you resolve the forces this way, your RQ is actually mg cos theta is actually 4/5 mg. Your frictional force, okay, it will be mu RQ. It will be 1/4 of the 4/5 mg. It will be 1/5 mg. And if you resolve the forces down the plane, you get the mq sine theta minus the frictional force, then is equals to the ma. So you are having mg sine theta minus the 1/5 mg is equals to the ma. Cancel all the m. Then you have this one 6 minus 2, 4. A is equal to the 4 meter per second. This is the acceleration for the Q. Okay, acceleration for the Q. What about the accelerations of the P? So over here, when the P reaches to the surface, reaches to B, the surface is already become rough. Then by right, the Q or the P also will moving in the same speed, same acceleration as acceleration. Sorry, acceleration is a ms -2. Okay, so by right, the accelerations for P and the acceleration for Q supposed to be the same. Why? Because they are having same mass and they are having same coefficient of friction. So they're supposed to be the same. Okay, so now we consider at P, the SB will be the 3D minus 0.5 plus the half of the A, B minus 0.5. Okay, so we consider this case, we consider at this moment, okay, we will try to consider at this moment the T is equal to 0. But at this moment, the TP is actually D minus 0.5. Because when the P reaches over here, the Q already reached down 0.5 second already. So we consider that the P start half second slower than the Q. Okay, we are considering over here that the P, when you P reach here, we start to count the time over here. That means the P is actually half second slower than Q. We will consider these situations. So therefore, we have this. Then you have this one as a 3t minus a 1.5. The 2t square minus the 2t plus the 1 over 4 plus a half. Okay, we are having this situation. Then at Q, we are having SQ as the speed of the Q. Also start from rest. Okay, they also start from rest. So the Q will be only the half AT square. This one is half AT square. Half A T square, you will get 2T square. Okay, so now we know that when they collide, SP is equal to SQ. That means the 2T square plus the T minus the 1 is equal to the 2T square. Cancel it, you get the T is equal to 1. Okay, so we are looking for the time that they collide. Okay, the time it takes for the instant two particles are released until they collide. Okay, so over here, to Q itself, the Q feel that after release 1 second, then they will collide. But to P itself, actually P itself, P will be taking half second, then they only collide. Okay, done. Now we go for the part C. The two particles coalesce when they collide. The coefficient of friction between the combined particle is still 0.25. Find the time it takes from the instant that the particle collide until they combine, until the combined particle reaches C. So when they combine, we need to use, okay, first of all, we need to find the velocity of P before the collision and the velocity of Q before the collision. So I will be using the formula U plus AT. I also will be using the formula of U plus AT. So for the P, the formula for this is supposed to be the 3 plus the 4 before collision. Before collision, the acceleration is 4. And the t, the time it takes is actually t minus a half. It takes half second. So it's a half second only. Then you get a 5 meter per second. Then for the Q, it will be, the beginning is a 0. Then with the accelerations of 4 and 1, you get a 4 meter per second. That are the speed before they collide. Okay, so by considering the principle of conservation of linear momentum, the MP, UP plus the MQ, UQ equals to the 2M when they collide. Then we have VC when they combine together. So from here, your VC is actually 9 over 2, or you can say 4.5 meter per second. Okay, so this is the combined speed after they collide. Okay, now after they collide, the mass has become 2m. This will become 2mg. The theta is still the theta. The r this time has become 2mg cos theta. Okay, 2mg cos theta. If you resolve it this way as well, then you can get 2mg sine theta minus the 2mg, I forgot to put the mu. Okay, your frictional force is 1/4 of the 2mg cos theta. Then it's equal to the 2ma. You can see that actually the answer over here, the A is still the same. Okay, the A is still the same. You can here 0.6. You can put here 6 minus the half of 8 is equal to the 2m. The m cancel already, 2a. So you are having 12 minus 4, 8/2, you still get a 4. Okay, so this process, you can see that after they combine, the acceleration is still a 4. Okay, so we actually do not need to show this in exam. We just know that the A still remain as 4 will do. But in order for explanation, I will still show you over here. So over here, this part is no need lah. This part is no need. This part is no need to show. Just to explain to you that after they combine, their acceleration is still 4 meters per second square. Okay, so now we have the speed after they combine. We have the accelerations after they combine. Now we want to find the distance that they need to travel in order to reach C. Okay, so for when the D is equal to 1, your SQ, you already travel half a D squared. Then you already travel 2 meters. So the remaining distance is actually 3.25 minus a 2 is only 1.25 left. So the D is equals to the 9/2D plus the half of the combined particle D squared. We're using this formula, but this time the D, I make it become 1.25. So just need to simplify it. You get this one as a 2D squared plus the 9/2D plus the 5/4 equal to 0. Multiply everyone by 4. I get 8D squared plus 18D plus a 5 equal to 0. Oh, I make a mistake. This is a minus. So you factorize it. You have a 4D minus 1 and a 2D plus a 5. So you get the D is equal to 1/4 and the D equal to negative 5/2. Obviously, the time cannot be negative. We ignore the D as a negative. Okay, so therefore, the time that they collide will be D equal to ½ second. Okay, so this will be the answer for the question number 7C. And this will be the last question for this paper. So I'll stop the video here. I'll see you next time. Bye-bye.